All right. Today we're going to see the equations for uniformly accelerated motion. So we're going to start off like this. The distance or displacement rather. So we're going to be using distance or and displacement interchangeably. The distance a body can cover is equal to the speed. Again, we're going to be using speed and velocity interchangeably, right? Because when we're talking about acceleration, basically we're talking about velocity. We're referring to velocity and displacement because acceleration is a vector, so we have to use displacement, which is the vector of distance, and velocity, which is the vector of speed. But just understand what I'm saying, that the distance a body can cover is equal to the speed times time. All right, so in physics we normally denote distance as s is equal to speed as v and time as just t. So s is equal to vt. Basically, distance is equal to speed times time. All right, so but if this body under consideration is accelerating, because that's the idea of today, accelerating, so there's acceleration going on. So what's acceleration? Acceleration tells us that, or rather, acceleration is the measure of the change of velocity over time. So for we to say that we have acceleration, it must mean that the body is speeding up, and if the body is speeding up, means that the velocity or the speed is not the same, right? The velocity has to change for it to say that the body is actually speeding up, because if the velocity remains constant, it is neither speeding up nor slowing down, so acceleration will be zero since there's no acceleration. But if we're saying there's acceleration, we're saying that the velocity is changing, and it's not just changing, because another key word there is, aside from acceleration, talking about uniform. Uniform simply means at a constant rate. It means that the speed is not just changing, but it's changing at a constant rate. So if the speed is changing at a constant rate, we cannot use this formula again, because we cannot just say the speed generally. We want to take a speed that we can work with. So whenever a quantity is changing uniformly, if you want to work with that quantity, you can just work with the average of that quantity. So what will be the average of this velocity? Well, the average is going to be the final velocity. So I'm just going to write it v average here. It's going to be the final velocity plus the initial velocity. All right, just write that, divided by 2. So anytime a quantity is increasing or changing at a constant rate, the average is always the initial value plus the final value. I wrote my own, the final plus the initial, but thank God addition is, it doesn't matter how you arrange it, addition will still work. 3 plus 2 and 2 plus 3 will still be the same. So initial value plus final value divide by 2. Now in physics, final velocity we normally denote it as v, which you're just seeing there. Initial velocity we normally denote it as u. All right, so I can rewrite this equation now. Since I'm working with the average velocity, I can now rewrite distance s will be equal to v plus u all over 2, times the time. So this is the formula we're going to use now, because we're saying that distance is the average velocity times time. So keep this aside. We're going to use this to derive all the equations of motion aside from one, which we're going to derive now. However, again, acceleration in physics, we say that acceleration is defined as the change in velocity. So this little triangle here, it means delta, it means change in velocity over what? Over time. And change in velocity basically means final velocity minus initial velocity over time. So in physics, we also denote acceleration as a. So I'm going to write a is equal to v minus u over t. All right, so if a body is uniformly accelerated, so please, all these equations I'm putting forth are for uniform acceleration, meaning that the velocity is changing at a constant rate. Now from here, let's make v the subject of the formula. We're going to derive our first equation. So we have to just cross multiply. We now have that v minus u is equal to at. So v is equal to, if I move negative u over, it becomes positive. So I have positive u plus at. Now this is our first equation for anybody that is uniformly accelerated. All right, so that's the first equation you need to know, that final velocity v is equal to initial velocity u plus acceleration times time. That's the first formula you want to know. Now the second formula, all we can do is now we are going to begin to substitute the values of one of the variables in this our first equation into this equation. So the second formula we're going to get, let's replace t. All right, let's replace the value of t in this equation. So let me highlight the equation. So we want to replace this t, all right, in this equation with the value of t here. So what we need to do is let's make t the subject of the formula from equation 1. So making t the subject of the formula, I discover that t would be equal to v minus u divided by a. This will give you t. Just move u the other side, becomes negative, then you divide everything by a. So this is the value of t. So I'm going to substitute this value to this equation. So I'm going to substitute this into this to obtain the second equation. So if I do that, I'm going to have s is equal to v plus u over 2, times, so I'm just going to put this in a bracket, times t. Now t is v minus u all over a. So let's solve that. We have x is equal to, now I'm just going to distribute. If you've done your algebra properly, you would have seen something already, that this difference of square. So my final answer is going to be v squared minus u squared. But just for some of us that are not familiar with this, let me just show you how I'm distributing. So v times v will give you v squared. V times u will give you negative uv. All right. Then I'll distribute again. U times v will now give you plus uv, and u times u will give you negative u squared. That's the numerator. All divided by, for the denominator, you have 2 times a, which is just 2a. So finally, you have x is equal to, you see that this minus uv plus uv will cancel out, and then that will be 0. So we'll have v squared minus u squared all over 2a. All right, let's go ahead and simplify. We're looking to make v the subject of the formula once more. So we just cross multiply. We now have that v squared minus u squared is equal to 2 times a times s is just 2as. So let's just make v squared the subject of the formula. We now have that v squared is equal to, now I'm going to move u squared over, it becomes positive. So I have positive u squared plus 2as. Now that's what we're going to. This is I missed that. So this is the next equation you need to know. This is the next equation you need to know. So we can just call it equation 2. All right. So let me just begin to highlight them. So this is the first equation. You can take that down now. This color is too bad, so I use a brighter color so you can see. So this is the first equation. We have v is equal to u plus at. This is the second equation. V squared, that's the final velocity squared, is equal to the initial velocity squared plus 2as. Now, to get the final equation